Hello and welcome to this session on Solve with Instructor on the content week 2 of MLF Foundations. I hope by now you have taken a look at the contents, you've watched the videos and practiced the activity and practice questions. So let's get started and solve some problems. I hope you can see my screen. Can I request you all to please open the peer deck session by opening joinpd.com. The code is written on the top right corner. I hope you can see that. 2LRNXJ. Please use this code. Yeah, good afternoon. Yeah, joinpd.com. Joinpd.com is what you have to open. All right, so let's get started to solve some problems.
And this pearldeck.com is also same as joinpd.com.
Sorry, which one?
Pearldeck.com is also pasted by Saktival K.
One second, let me check.
app.pearldeck.com.
Yes.
Okay, both are same, right?
Yeah. So it's basically peer deck only. So yeah, that's fine. Yeah. Can you see this question? All right. Yeah, I hope you can see this question
Yes, ma'am.
and the options that you have to fill in. So can I please request you all to solve this question at your side, and then I'll help you do it. So here we are
Yes,
given
ma'am.
a function
Sure.
and
Yeah.
and we have to check whether the function is continuous at x is equal to 0 or not. Right. So how do we check whether a function is continuous or not? We check three things. We check the function's value at that particular, and we check the left hand side limit and the right hand side limit. If these three things are same,
Right hand side.
yeah, then we say that the function is continuous at that particular point. So please compute these three things and please add your answer in the screen that you might be getting. And then let's see what you get.
Ma'am, here means both is less than and less than equal to. Is
I'm sorry. Yeah. Has to be, the bottom one should be greater than.
Okay.
Yeah, I'm sorry. I'll fix it.
Bottom one is greater than.
Bottom
right?
is greater than. Yeah.
Okay.
Okay, I see 25 people have joined, and there are some 40 people in this session. Can I please request everyone to join the peer deck session? Start adding your answers there so that we are on the same page.
May I ask a different query? Like we have a two session at same time, like match two session and machine learning foundation session at same time 2 to 4. So if, we mail in the support team, but no reply yet.
I'm sorry, Yesh, I couldn't understand what you're saying. Can you please repeat?
I just want to say that there is two sessions going on for diploma student, maths 2 and this session. Both are going simultaneously.
Match 2 is foundations, right?
Yeah, but for diploma student, they are doing both simultaneously. They can do, I mean,
Oh,
direct entry
then
student.
yeah, then the session
Yeah,
at the same time. So the
Yeah.
timings are 2 to 4.
yeah, same. Yeah.
Oh, this has to be checked.
So I think what he can do is that he can watch a recording for one of the session.
Yeah,
That might be
yeah,
helpful.
you can do that, but the first place, this should not happen. If in case you are interested in attending both the sessions, they should not be on the same time. So
But ma'am, as there are many of the session and there are a lot of subject, it is not possible to, held all the session, on
yeah,
different
that is
time.
also there. We do
Yeah.
have limitation there.
Yeah, and in diploma you can take any of the subject. It is not fixed that you have to take only. You have to choose only in the core of the subject, like in the foundation level. So I think it's not possible.
Happening. Yeah.
Yeah.
How many such people might be there? If the number is huge, we should actually try to keep them
Yeah. Yeah.
different times. How many such people? Any idea?
I think there are 3 to 4 people because yesterday in the
Okay, that's fine.
yesterday session also there are some people who was asking the same question.
Okay, let me check this if it is possible.
Yeah.
Did you post it somewhere? So where you did not get any reply? Something you said I couldn't get that exactly.
I don't know who asked, but
Okay, never mind. Let me check this and see. So if it is possible, it will be changed. If it is not possible, it will be same. I will try that. Okay, so I got 19 responses from people who have joined the peer deck session out of 48 people, out of 48 participants in this session. Okay, let me take a look at the responses. 3 people have filled in no, which is incorrect. So let's quickly see how that is. So, so this is the function that is given, uh, less than equal to 0 and greater than 0. So we have to first compute f of 0, the above part we will do. So f of x is equal to right. So f of 0 is 0, right? And if we have to compute left hand limit, again we have to use the same this term, and again we'll put 0 and we will get 0. For right hand limit, this is greater than 0. So for right hand limit, we will use this bottom thing, which is x. So when you put x is equal to 0 here, this becomes 0. So all the 3 things are same.
same.
So we can say that this function is continuous. Simple. So people, three students who filled in no. I hope you got the idea. I hope you would have corrected your mistake. So let's go on and see the next question, which is similar. So I hope you all will be able to do it now that you know how to check for continuity. So let's see how this function is continuous or not.
Yeah, just a question. Sorry.
Question?
Yeah, sorry to interrupt. Just a question that differentiability of a function at a point also contributes to the continuity, right?
Sorry, your voice is not very clear to me. Please, Kizar, can you repeat your question?
Yeah, I'm sorry. Is my voice clear now?
A little better.
Okay. I was just asking that differentiability of a continuity also contributes to the continuity, right?
Differentiability and continuity what?
If a function is not differentiable at a point,
Yeah.
then we cannot say that it's continuous, right? I mean, differentiability should also be checked. Is that the case? I'm just asking the question.
Correct. Okay. So if a function is continuous, it may or may not be differentiable. Okay. So if you have to check for differentiability, you will first check for continuity. If a function is continuous, it may or may not be differentiable. Okay. I think that was your question.
Yeah, yeah.
Okay. Okay. Yeah, we had taken a couple of examples in the last session on the very same thing. Maybe you can check that out once.
Okay, thank you.
Okay, so let's see what you filled in for this particular question. The correct answer is no. Two students have filled in yes, which is incorrect. So let's quickly do this question before we move on. So here, fx is to be x square sine 1 by x plus 3 if x is not equal to 0 and 1 if x is equal to 0. So this is given and we have to check for continuity x is equal to 0. So f of 0 is given to be 1. We're done there. Now left hand limit, for that we will be using this particular equation, and for right hand limit also we will be using the same equation. Now so x square sine 1 by x, when you put x is equal to 0 to get an approximate value of left hand limit or right hand limit, you see that this is division by 0 which is happening, but you also know that this is not exactly 0. It's not x is equal to 0 exactly whenever you are computing left hand limit or right hand limit. For left hand limit it's a little less than 0, for right hand limit it's a little more than 0. So in that case division by 0 will not happen. Now, one property that you can make use of over here is that sine dash. What is the value? What is the range of values that sine dash can have? No matter what value you put in here as a parameter, the sine value will range from -1 to 1, correct? And then in order to get an approximate value for the whole term, you 0 over here and the whole thing will become 0, and what remains is 3. You get 3 as the left hand limit and right hand limit. Your f of 0 was 1. So since these three things are not equal, so the function is not. Is this clear to everyone? I hope that was clear. So now let's move on to the next question.
Do we have to check for all the three things to be equal or only two, left hand limit and right hand limit?
For all three. In some cases, left hand limit and right hand limit might be same, like in this particular case, but they may not be. For example, for left hand limit here, you will check the upper equation, minus x plus c. For right hand limit, you will check for the bottom equation. So you have to compute all three things. Okay.
Okay, ma'am.
17 out of 36 people have answered. So again, you will use the same thing. You will compute left-hand limit, right-hand limit, and the function value at x is equal to 1. Equate them, and whatever value you get for c, that's the answer. Two people have done it incorrectly. Okay, so most of them have given the correct answer except three students. So the correct answer is 5. All right, so let's quickly see because the next question is also similar. So here we are given minus x plus c. If x is less than equal to 1 and 6 minus 2x square, if x is greater than 1. So that's what we are given. Find the value of c and continuity at x is equal to 1. So f of 1, we'll use this thing, and putting x is equal to 1, we get minus 1 plus c. Left hand limit will also be same, correct? Right hand limit, x is greater than 1, this is what you will be using. 6 minus 2, x square, you put x is equal to 1. So this is what you get. Now, in order for the function to be continuous at x is equal to 1, these should be equal, which means minus 1 plus c should be equal to 4, c should be equal to 5. Simple, right? I hope those who entered the incorrect answer have seen your mistakes. All right, let's move on to the next question, which is also similar. Now, let's see whether this function is, no, this function is continuous. Let's find the value of c. Okay, let's see the answers. The correct answer is D, which is minus 4 by 9. One has incorrectly answered 4 by 9. Please see that. So, do you want me to solve this, or this is clear to you? Okay, I hope this is clear to you. So, I'll go on to the next question. In case you want me to solve it, please let me know. Our next question is, we are given this piecewise function where three different equations of the function are given. We have to find all values of x where g is not continuous. I'll give you some time before I explain which points to look for. All right, so here we have to find all values x where g is not continuous. Now, which values you should try? It might be the first question. So, firstly, it's a piecewise function, right? So there's a separate equation of the function when x is less than equal to -1. As x is greater than -1, the function's equation changes. Similarly, the when x becomes greater than 1, the function equation changes. So these are the points where a discontinuity might happen and we might need to check. So in case of such a piecewise function, you should check for these boundary points for each piece of the function. So x is equal to -1 is one contentious point where we should be checking. Another point should be x is equal to 1, where we should check for continuity of the function. Other points where we should check for continuity are found checking the denominator.
Denominator could be 0, right?
Correct, correct. So if denominator is equal to 0, the function becomes undefined at that point. So we need to check whether that is happening for the given function or not. So denominator we have x is equal to -3 and x is equal to -2. There are two more points where we should check for continuity. So these 4 points, check them one by one, and you will get to know the values where the function is not continuous. Out of 56, only 40 people have joined the peer deck session. I request you all to join. If you're attending this session, why not join and try answering the questions as well. That will keep your interest in the session and you'll get to learn something. Okay, let's take a look at the responses. 1, 2, 3 people have entered incorrectly, and 10 people have not entered anything. So the correct answer is -3 and -1. People have entered 6, 1 and 0. I don't know how you got that. 6, 5. I don't know how you got that. Maybe you can explain if you can. If you tried solving and got something, maybe you can explain how you got 6 and 5 there. Anyway, so as I said, we will check for 4 points: -1, 1, -3, -2. So I'll quickly do it for those who could not do it. So let's check at x is equal to -3. So let me note this down quickly. Less than equal to yeah, so x is equal to -3. X is equal to -3. This thing will hold. There is one. Okay. So when you put x is equal to -3, you get division by 0, which is undefined. So the function is not continuous at x is equal to -3. Next point to check is equal to x is x is equal to -2. For that, again, the same equation will hold. All the three values will come out only this equation. So when you put x is equal to -2, you get 1, right? And you get 1 for all three values. So the function is continuous at x is equal to -2. Next point to check is x is equal to -1 and equal to -1. This equation will hold. F of -1 will be equal to 1 by 2 square, will be 1 by 4. Now left hand limit, x is less than equal to -1 will also be 1 by 4, correct? The same equation will be used. And right hand limit, x is greater than this equal to 2 minus x, 2 minus -1, which is +1, which is 3. Now these three things are not same, so the function is not continuous at x is equal to -1. Next is x is equal to 1. Okay, for x is equal to 1, this equation. So f of 1, 2 minus 1, that is 1. Okay, left hand limit, x is less than 1, the same equation will hold. Right hand limit, 3 by x plus 2. 3 by x plus 2. Okay, 3 by 3, that is 1. So all three things are same, so the function is continuous. So the points of non-continuity are x0 -3 and -1. So I hope you did the same way. Okay, let's
Ma'am, how at x equal to 2 the function is continuous? -2.
x is equal to -2. -2 means -2 is less than -1, right? So this particular equation will be used. This equation will be used. 1 by x plus 3 square. So when you put x is equal to -2 in this, what do you get? 1 by 3 minus 2, 1 square. 1 by 1 square, that is 1. This equation, just use this equation.
Yeah.
Okay, ma'am. Thank you.
Ma'am, can I ask something?
Yeah.
Like as you said that if we have to check that whether at this point function is continuous or not, then we used to check left hand limit and on this point and then right hand limit, right?
Yeah.
So like at any given point, if it is coming like undefined and also the nearby point also coming undefined, then it will be continuous or not?
No, undefined is never continuous.
Never will be continuous, right?
Yeah, it will never be continuous. Undefined means the function is not defined for that.
Function is not defined.
Yeah, no, function is not defined, which means there is some,
Point.
yeah, let's say this region, the function is not defined. So there's no,
Okay. So even when the nearby point is also coming undefined, then also
yes,
it will be, yeah.
let's say this point. this point. Okay.
Yeah.
And,
Yeah.
and the nearby point is also undefined, correct?
Yeah. Yeah.
But that doesn't mean that the function is continuous.
Yeah. Because function itself is not defined.
Yes. Yes.
Thank you.
Okay. Next. Next question. All right. Now let's move on to linear approximation.
Yeah.
What is the approximate value of square root of 9.1? So let's say you don't have calculator and you have to compute, you're expected to compute the approximate value of this particular term. Now, you know the approximate value of square root of 9, right? So you make use of that, make use of the value of square root 9 in order to compute an approximate value of square root of. So think about the function that should be taken in this case. The function should be taken as, tell me.
X.
Square root of x, yeah. And what should be the value of a here?
9.
Yes. A should be whatever value you know.
And can we take 2 minutes of time for solving this question?
Yeah, sure, sure. Okay, let me tell you the formula for linear approximation in case you don't recall. So linear approximation of x is equal to f of a plus f dash a into x minus.
Now, if the linear approximation, if this function is two-dimensional, then it would be x minus b comma y minus b, right?
Khizr, okay, I'm just trying to guess what you asked. So in case it is a multidimensional function, yeah, it will be dou f by dou x, x minus a plus dou f by dou y, y minus b, right? And the point will be a comma b. Is that what you're asking? Khizr, can you hear me? Khizr, is that what you were asking?
Yes, ma'am. He wrote yes in
Yeah.
the chat box.
All right. I'm sorry. I'm somehow not getting notification for chat. Okay. Okay. 24 out of 40 only have done so far. I'll give you 1 more minute and then I'll.
Ma'am, till how much decimal we should take the value?
It should be given in the question, but not if not given, 3 to 4 decimal points should be sufficient. Okay, here. Okay, here we have mentioned, but if not mentioned.
Yes, ma'am. Here it is mentioned. I'm just asking that.
Yeah, 3 to 4
Generally.
should count. 3 to 4 should be fine in general. Okay. Okay, let me quickly do it. So linear approximation. I hope the reason why we do it is, I hope, clear to you. To get, there are many advantages we discussed last time to get approximate values of value of the function at places where you cannot directly compute, like in this case, point one, you'll be able to quickly calculate it if you know what is square root of 9. So that's one advantage. Second is to simplify your models. You get a linear equation for any higher order function. All right, getting back here, you should know what function should be taken. So here, square root of x we would be taking as the function, and linear approximation requires f of a, f dash of a. You need first order derivative. That will be 1 by 2x to the power minus 1 by 2. That will be your derivative. And a we will be taking 9 over here because we know square root of 9 then. So f of a will be square root of 9, that is 3, and f dash a will be 1 by 2 square root of 9, 1 by 6. Now putting the values in the above equation, we get 3 plus f dash a is 1 by 6, x minus 3. So this is what we get.
X minus
Sorry.
X minus 9, ma'am.
Yeah, correct. X minus a is 9. Yeah, f of a is 3. This is what we get as the equation. It's 3 plus x by 6 minus. This is what we get. Now we are asking square root of 9.1. So this equation you can make use of. So it's a linear equation. You can make use of this equation to find the function value as long as you are near 9. Okay, 9.1 is near 9. So this equation should be able to do a good job for us. As 9.1 divided by 6 minus 3 by 2, whatever it comes out to be. I think if you put here, that will be better. 3 plus 9.1 minus 1, 0.1 divided by 6. Whatever you get out of this, that should be the correct value. And if you compare it with the actual value using calculators, square root 9.1, if you compute, these two should be more or less same, these two values. You can check that out. Okay.
If the value, I mean, the given thing is root 10, then I mean, linear, we should take quadratic.
No, again, square root of 10, right?
Yeah.
So why should you take?
Because the point is like, if you take a is equals to 9, then the difference is like little.
Yeah, difference is a little higher. So in that case, what will happen? The equation that you get, this equation, when you put x is equal to 10 here, you get a value which is not so exact like this one. I think this will be more or less same. Okay, in case of square root 10, there'll be some difference in whatever value you get out of this approximation and whatever the exact value is. But in any case, you will take the function to be a known value, right? Then only the advantage of doing all this comes in. Okay. Why did you think of a quadratic one? The function is a square root.
No, I'm saying the linear approximation as a quadratic approximation, because then because it is far away, right?
Okay, you mean to say instead of linear approximation, you take higher order approximation.
Yeah,
Okay,
yeah.
I get it. So yeah, so if you go for higher order approximations, you will get a little better value as you keep increasing the degree. Approximation will be better if you can go for that. Okay, so most of
Depends on the accuracy that I want, whether I will use linear or higher order.
so it depends. You know, the question that was just now asked. Since you are far away, so 9 and 10, there is a good difference as compared to 9 and 9.1. Since you are away from the value, the known value, you might want to go for a higher order approximation. If you want to get a good approximation, if you don't want to compromise there, you can increase the degree of approximation. If you're okay with the little deviation between, let's say, actual value of square root of 10 and whatever this equation gives you, if you are okay with a little difference, you can still continue with the linear approximation because you want simplicity. So it's up to you. Okay. Is that clear?
Yeah. Okay.
All right. Let's move on to the next question. Find the linearization. Linearization is same as linear approximation of a cube root function. So I hope the question is clear to you. What you are expected to do here is to tell the linear approximation. The equation is required here. A is given here to be 8. Okay. You should come up with an equation, linear equation that approximates this function.
We have to write linear equation or value.
So you're getting something like this. Okay, you write the equation. We'll check. You write the equation. Okay, all sorts of innovative answers we're getting from you. So actually, this is the correct one. 2 plus 1 by 12 x minus 8. I mean, you would have written it in some other form probably. So all of them are correct. So f of x here is cube root of x, which is x to the 1 by 3, and a is given to be 8. Now f dash x will be equal to 1 by 3x to the 1 by minus 2 by 3, right? So f of 8 will be 8 to the 1 by 3, which is 2, and f dash of 8 will be 1 by 3, 8 to the power 2 by 3, which is 8 to the power 1 by 3 square, which is 2 square, which is 1 by 12, right? I hope you all got that.
This
So,
is x power minus 1 by 3.
sorry, which one?
It is cube root.
This one? This one?
Yeah, 2.
This is denominator.
Oh, okay.
So L of x will be f of a. F of a is 2, right? F of a plus f dash a, which is 1 by 12, x minus a. So this is what you should be getting. Now, if I ask you to, let's say, compute the cube root of 8.1. So this is something that may not be straightforward for you to compute. So you can use this equation to quickly find that value, because a is here and 8.1 is in the vicinity of it. So can you try and tell me what value you will be getting by using this equation? We are not asking it here, but you can try, and something 2.0083 is what you will be getting. Yeah, yes, that is correct. Okay, let's move on to the next question. Compute the linear approximation of 1 plus x to the power n at x is equal to 0. So again, you have to find the equation of linear approximation. Yes, you have to enter the equation itself. Okay, let's quickly see the linear approximation of 1 plus x to the power n. F(x) is equal to 1 plus x to the power n, and x is given to be 0, which means A is given to be 0, f dash x is equal to n into 1 plus x to the power n minus 1. F of A, which is f of 0, will be 1. F dash A, which is 1 plus x is equal to 0 to the power n minus 1. Into 1, that is your n. The linear approximation will be f of A 1 plus f dash A n into x minus A 0. Yeah, 1 plus n x is what you're getting. So you see, this is an nth degree function, right? The power is n, which could be, let's say, 100 also. Okay, it's a 100-degree function, and then you compute a linear approximation of that function, which comes out to be 1 plus 100x, right? The equation gets converted into the power of x is equal to 1 simply. So you can very much simplify your equations by going for linear approximation. Now let's move on with the same question. Use that approximation that you got in the previous one to compute an approximate value of 1.01 to the cube. 1.01 cube. So can you use the approximation that you got in the previous question to find the value of 1.01 cube? Tell me what you get. A couple of students have entered an incorrect answer. Okay, let's see. So when for a general function with n, the linear approximation was 1 plus nx. Now in this case, n is equal to 3, correct? And what do we want to compute? 1.01. And the function that we had taken was 1 plus x, which means our x should be equal to 0.01. Correct? Which means we have to find the value of 0.01. Please note this, this is important. I think this is the mistake that some of the students might have done. So 1 plus n is equal to 3 here, x is equal to 0.01 here. Okay, so we get 1 plus 0.03, 1.03. This is what you should be getting. Yeah, many students have done it incorrectly. So you have to note what should be which function which was the function that was used to approximate. Okay, one more thing I should highlight here. Let's say the question is simply this: compute the value of this 1.01 cube. 1.01 cube. Let's say you forget about the previous question. You have to compute this value. How do you go about it? One way would be to take f of x is equal to x and take a to be equal to 1. Okay, and then go on compute the value of L, which is linear approximation, and then compute the value of 1.01. In this equation, you put x equal to 1.01, and you will get the same answer that you got here, that is 1.03. Whatever we followed was another way out. What we followed was, we had taken f of x to be equal to 1 plus x and use that to find the value of this. So both ways should work. That's why whenever you have to find some value, you should see what should be your x, or should be your a, or should be your f of x. So that's something to note. I hope this point is clear to everyone. You can actually try it yourself. You can take f of x is equal to x cube, and then, okay, let's do this. F dash x will be equal to 3x squared, and f of a is equal to 1. F of a will be 1. F dash of a will be 3. Then linear approximation will be f of a plus f dash a into x minus a. 1 plus 3x minus 3. 3x minus 2. Okay, this is what you get. Linear approximation that you got earlier was 1 plus 3x, right? 1 plus 3x, that was different. Why? Because the function taken was different. Now in this case, 3x minus 2 is the linear approximation, the function taken is different, and accordingly you will be using. Now, if you use this equation to find L of 1.01, you will put x is equal to 1.01. Okay, so 3 into 1.01 minus 2. Okay, 3.03 minus 2. 1.03, right? You got 1.03 here, you got 1.03 here also, but with a different function and different linear approximation. I hope this is clear to everyone. Okay. Moving on to the next question. Okay, maybe you can also let me know whether you are able to understand things or not, so that I get some feedback and get to know that you are understanding. Quickly answer this. This should be quick. I hope everybody would answer it. Okay, let's. Oh, some people are confused. 3 people are confused. Isn't this interesting to fill in? Okay, somebody wants to stop as well, is it? No. Okay, 3 people are confused, and 1 person is not sure what to fill in. Looks like it. Okay, 3 people who are confused. Maybe you can please ask me. Whatever we have discussed so far, you can please ask me. Okay, 1 person is moving on to. Okay, keep going. It's getting a little funny. Okay, on a serious note, you can please ask me whatever we have discussed so far. If you're not understanding, I'll brush it up again for you so that we all are understanding. Okay, somebody needs help. Please unmute yourself and ask me what is it that you did not understand, and we would take it up again before we move on. Okay, you can interrupt anytime, you can ask. All right, let's look at the next question. Compute the cubic approximation. So far, what we did was linear approximation. Now, let's move on to cubic approximation, which means approximation of third of this function at a is equal to 1. So you have to give
cubic and quadratic are same.
Quadratic is second.
Oh, okay.
Ma'am, I have a question. Do we have to remember these approximations in the examination also? Like the cubic one, because I remember until quadratic, but cubic I don't know.
So there is a pattern actually. Yes, you need to remember. There's actually a pattern, and that will help you to compute any order approximation. So linear approximation we did, and then let's say second order approximation. So f of a plus f dash of a into x minus a was your linear approximation, right? You stop there. But if you want to go further, you will add one more term, which means you will go for second order derivative and then second order term and then 2 factorial. If it is a cubic approximation, you will add one more term, which is third order derivative and third order term and 3 factorial. Very simple. If it is the next order, fourth degree, you will add, I hope the pattern is clear to you. Okay. So you should remember this. This might be handy. Very few people have entered the answers so far. Okay, I'll write the answer and you can tally whether you're getting this or not. You may check whether you're getting this or not.
And this is the simplified form, right?
I'm sorry.
This is the simplified form. Which answer you wrote?
Yes, yes. This is the answer.
Yeah.
This is the expansion series of 1 plus x whole to half.
I'm sorry.
This is the expansion series that 1 plus x whole power half.
No, no, no. This is the linear approximation. Sorry, not linear approximation. Cubic approximation. This is the formula that you will be using for getting a third degree approximation.
No, when we expand the series of 1 plus x whole n, and when n is equal to say.
You're asking that way. Yes.
Yeah.
Sort of an expansion. Correct.
Yes. So any expansion series. So there is say 1 plus log x expansion, sin x expansion.
Yeah.
So in expansion series, it is a kind of approximation only in higher order.
Yes, yes, you can say that. Yes, you can say that. Because how do you get that approximation? You use Taylor series, and this is what you get out of Taylor series itself. Okay.
Mm-hmm.
Yeah.
Sure.
All right. So should I solve it, or you are able to do it? Please tell me whether you got this or not.
Yeah, got it.
Okay. Let's see. Okay. Okay, some people would have written the answer in some other form probably. You may check that, just tally whether you're getting this or not. But some have entered completely incorrect answer. I don't know how they got that. Please let me know if I should solve it. Okay, some are completely incorrect.
I haven't simplified it.
Okay, okay, no problem. That you can see. That's why I've written the answer there. You can tally.
Yeah, but I got the same answer after simplifying.
All right. If you want me to solve it, please let me know. I will do that. Or we can move on to the next question.
Move on, ma'am.
All right, Shruti. Okay, find the linearization, which is linear approximation of f of x is equal to this function. Now, what difference has come in here as compared to whatever you did so far? Can you tell me?
Yeah, instead of 1, there is 2 variables.
Correct, correct. There's a typo here. It should be f of x comma y. It's a multivariate dependent on x and y. So f of x and x comma y considered that way.
X and y.
Yeah. And the point now that it's a multivariate function dependent on two variables, the point will have two coordinates. This is a comma b. Make use of this, and instead of derivatives, you will make use of partial derivatives. Please go on.
Ma'am, formula will be the same only, no?
Yeah, let me write the formula for you. So if it is dependent on two variables, let's say x and y, so instead of f of a, you will write f of a comma b, and instead of f dash x or f dash a, you will write dou f by dou x.
Yeah, that's obvious.
Comma b into x minus a plus dou f by dou y at a comma b.
F dash a comma b.
Y minus. Yeah. Yeah.
Should we expand sine x minus y like sine x cos y minus cos x sine y like that?
No, there's no need of that. All you need is the derivative, right? Dou f by dou x. You should just know the derivative of sine.
Okay, yeah. Sorry.
Okay, very few people have entered the answer. Okay, let's see. F of x comma y is given to be e to the x sine minus y. Okay, and the point 0 comma 0, a comma b will be 0 comma 0. Now let's see dou f by dou x, what that is. So e to the x sine, e to the x derivative same, and then x minus y same, and then e to the x derivative is e to the x, and then sin x cos x minus y. We are doing with respect to x, y is taken as constant, so that's it. Dou f by dou y, with respect to y this becomes constant, and then sin x cos x minus y, x is constant, y minus 1. So this will be your dou f by dou y. I hope you got the same values. Now dou f by dou x at 0 comma 0 will be e to the 0 1, e to the 0 1, sine 0 0 cos 0 1. Okay, should be 1. Dou f by dou y at 0 comma 0, e to the 0 1 minus cos 0 1, so it should be minus 1. Okay, now linear approximation will be, and f of 0 comma 0.
Excuse me, ma'am. I have a question.
Yeah.
Dou f by dou y, it will give.
Yeah, dou f by dou y. Go on.
Yeah, got it. Like I think if it is cos x, it is going to be minus x. Okay, fine. I'm confused.
Okay. Okay, f of 0 comma 0 is 1, and then sine 0 0. So this is the 0. Linear approximation will be f of 0 comma 0, that is 0, plus dou f by dou x at 0 comma 0, which is 1, into x minus a is 0, plus dou f by dou y at 0 comma 0, which is minus 1, into y minus b is 0. Okay, so this is what you should be getting, and then x minus 1. This should be your answer. Many of you got the correct answer, so let's move on. Okay. Okay, what about this question? Compute the derivative of this function in the direction of this vector at the point 3 comma 2. Would you do it?
Find the z and then unit vector, then
Yeah.
carry.
This is a question for directional derivative. Okay, you have to find the derivative of a function in a given direction. Whenever you are given a direction, you have to make sure that that is a unit vector. If it is not unit vector, first convert that into a unit vector by dividing it by the magnitude of that vector. So 1 comma 2 is the vector, which is not a unit vector, convert into that form. And then in order to compute the derivative in a given direction, you will use directional derivative, which is nothing but the weighted sum of partial derivatives. Okay. So make use of that and let me know what will be the value of the directional derivative. Okay, very students have entered the answer. Let me do it so that the concept of directional derivatives is clear to you. Okay, what are we asking? F of xy is equal to x squared y, right? In the direction point is 3, comma. Okay, we need, so what is directional derivative? Directional derivative is the weighted sum of partial derivatives. And precisely what that is, gradient of f dot product unit vector of direction. Okay, now let's compute both these things. First, gradient will be 2xy, which is your dou f by dou x, and then dou f by dou y will be x square. This is your grad. Okay, grad f at 3,2. Let's see what that is. Okay, at 3,2 will be 12, 9. Okay.
Grad directional derivative grad f transpose.
I'm sorry.
Ma'am.
Just grad f transpose in dot u. Because normally grad f is a column vector, right?
Yeah, it's a column vector. We are just for the sake of convenience, we are writing.
In equation, you are yes. In the equation del f t, dd is equal to.
We are taking dot product, so it does not matter.
Yeah.
We can write it. We can write it horizontally, right?
Yeah.
In a row.
This is a dot product, not multiplication.
But we are doing the transpose to make it row vector, right?
No. I've just written. You can write it like this. You should write it like this. I have written it just for saving space. That's all. Indeed, it's a vector. It's a column vector, like this.
Yes.
You can write it that way. Then you also
one-to convention, just confusion. When somebody is saying ki, there is a vector of d dimension, then what in what way I should represent that? It is a column vector or it is a row vector?
It's actually a column vector. It's actually a column vector. It's a three-dimensional column. But if you're writing it in a row form, you can put a transpose there.
Yes, okay. But normally it is a column one.
Yes.
I am doing the transpose because of my convenience.
Yes, correct.
And whenever there is a point in any coordinate, is the is representation. I should represent in a row vector or in a column vector.
Like this. This is the general convention for a point.
This is not a vector at all.
Yeah, it's a point.
It's a point.
Not a vector. Yeah, not a vector. This is the general convention for vector representation. This is for a point. Okay.
Go ahead.
Okay, so where were we? Grad f at 3,2 we had computed it to be this one, and now the unit vector we have to compute. The given direction is 1, 2. So let's convert it into a unit vector form by dividing it by the magnitude 1 square plus 2 square, that is square root of 5. So we get 1 by square root of 5, 2 by square root of 5. Okay, so this is our unit vector. Now we take dot product of now we take the dot product of grad f and u, and that will be your directional derivative. So basically we have to take the dot product of 12 and 9 with 1 by square root of 5 and 2 by square root of 5. This is what it is, and to get this plus this is what you should get. Yeah, this is what you should get. You can compute this. This should come to be 35. So this should be your answer. Let's see what you entered here. 13.41. Okay, these people are correct. This is completely incorrect. So please check whatever mistake you had.
Ma'am, how do we differentiate between x ki power 2y and x square y? I thought it was x power 2y.
If it had been x to the power 2y, there should have been a bracket actually.
I thought it was x power 2y.
It should be a okay. Confusing. Should have been this way. But in general, since the bracket is not given, this okay, you can note that. You might come across such a convention also at some places who are not mindful enough to make it clear like how I did. So the general thing is they should have if the y was in power. Okay.
Okay, ma'am. I'll keep that in mind.
All All right. So I hope this is clear to you. Now let's move on to the next one. For the question in the previous, for the function in previous question, compute the derivative of f in the direction of 2, 1 at the same point. Okay. So now this is a revision for you. The direction is changed now. Earlier the direction was 1, 2. Now it is 2, 1. Now I hope you have understood. Now let's. Can everybody please mute? Mute yourself. Okay. Am I not audible?
No, ma'am, you are audible.
Okay, I think that was old. Okay, okay. I think that was earlier message. No, Pallavi is not able to hear me. Maybe she can rejoin. Okay. Responses yet? So I want to make one thing clear here. I want to highlight one thing. You see, when the direction is different, there's a different derivative. So for any given function, there are different values of derivatives, which precisely means the rate of change of function. So when you change the direction, you get a different rate of change of function. So that's what I want to highlight here. In the previous case, the derivative was 13.41. That was the rate of change of function in the direction 1, 2. Now, in the direction 2, 1, let's see what value of derivative we get for the same function, same point.
Ma'am, in the directional derivative question, we are finding the derivative, right? So if I just do not change the direction, but I am okay, I mean, in the same line I am taking above, then it should become same, right?
Yeah. So let's say here the direction was 1, 2.
If I take 2, 4, that means I am not changing the direction, but I am just scaling it above.
Correct, correct. Yes.
So in that case, it will remain same.
It should come out to be the same. Yes, because what you are using is the unit vector, correct? You're not using the magnitude. You're not concerned about the magnitude of this vector. Only the direction you're taking. So the unit vector will come out to be the same, and hence the directional derivative will be the same.
And when it is perpendicular, then it becomes 0.
Correct, correct. We will get one question in file on the same thing. We'll see that. Okay, let's see what you're getting. Okay. Okay, the correct answer for this question is 14.75. Those who got this, so if you've got some different answer, you may please recheck. So some students have given completely incorrect answer between 0 and 5. Please recheck your answer. It should be 14.75. So you see, when the direction was 1, 2, the rate of change of the function was 13.541, and now it is 14.75. So you can compute the how the function is varying in different directions by using the concept of directional derivatives. I hope this is clear and we can move on. If you want me to solve, let me know. Okay. Okay, now we are continuing with the same thing. For the same function, you have to tell in which direction is the derivative maximum. So you have to basically tell the direction. That should be your answer. In which direction would you get the maximum derivative? So in one direction we got some 13 point something, in another direction we got some 14 point something. You want to see in which direction we would get the maximum rate of change of function. How do you do it? No, 2, 1 is okay, not out of 1, 2 and 2, 1. Somebody has entered 2, 1. I'm not asking out of 1, 2 and 2, 1, which is giving you maximum derivative. No, the question is not that. Check, I mean, consider all possible directions and tell, I mean, I don't want you to try all possible directions, of course. Out of all possible directions, which will be the direction in which you will get the maximum rate of change of function, is what the question is.
We take the double derivative, right?
12 by 15 and 9 by 15.
Yeah, that's correct. How did you get that?
Because in that case, I will take this derivative, I mean, grad is 12 by 9, and since this v is equal to alpha v for the maximum condition, so alpha to be 1, that's 1 by norm. That means 1 by 12 square plus 9 square root.
Correct. Yeah, so we had discussed this in the previous session also, that gradient always points to the direction of maximal directional derivative, that is the steepest direction, right? We talked about this, that gradient always points to the direction of steepest ascent, which is the direction in which there is the maximum rate of change of function. So in order to get the direction, you will just use the grad f. Okay, now direction is generally given as a unit vector, so you convert that into a unit vector. So grad f, I think we had computed, that was 12, 9. Okay, 12, 9 was the grad f. It was not a unit vector, so let's convert into a unit vector form, and you will get the direction, that is 12. Let me write it here. 12 divided by 5, this should be 12 divided by 5, 9 divided by, sorry, 15. That is your 4 by 5, 3 by 5. This should be the direction that will give you the maximum rate of change of function. Is this clear to everyone before we move on? Because that will depend on this answer. Any doubts?
Can you explain it again?
Okay. Okay, please keep this in mind. We in detail spoke about this. Gradient always points to the direction of maximum ascent, which means maximum rate of change of the function. Okay. Now, in this question, we are asking in which direction will the derivative be maximum, Derivative is rate of change of function will be maximum. So that is gradient. Gradient was 12, 9, right? This was your gradient. Okay. It's a good idea to answer a direction in the form of a unit vector. So you convert into a unit vector form. Okay. Yeah. This is your answer.
Is this same as maximum global or local maximum?
So it depends on the function, whether the function has a global maximum. So, but here we are not concerned about that. What we are concerned about is a point is given, right?
Yeah.
How did you get this 12,9? You got that. So this was your derivative.
Yeah.
You put in the value 3,2. That was, yeah, this point 3,2 was given, and so you're actually not concerned about local or global minima in this case.
I'm just asking that it is similar or different.
So it's actually I would say irrelevant here.
Okay,
So
this is not related.
You're at this point 3,2, and
Yeah.
there are different directions. Like assume this to be a bowl. I mean 3D plot. Okay.
Yeah.
So there are different directions that you can go in. Okay.
Yeah. Yeah.
Which is the direction that will give you the maximum rate of change of function. That's all. There's no local global here. Okay.
Local.
Right.
Yeah. Thanks.
Okay. I hope this was clear. Now let's move on to the next question. For the same function, what is the value of the maximal derivative? Okay. So now you got the direction. This is the direction that gives you the maximum rate of change. Now use this as u, and then find the value of directional derivative. In one direction we had got some 13 plus, in another we got some 14 plus. Now this should be greater than this. Why? Because this should be maximum. Let's see how much that comes out to be. Okay. Let's see your responses. Okay. 1, 2, 3, 4 people have entered an incorrect answer. The correct answer is 15. The correct answer is 15. Just use that vector as a unit vector and multiply it with the gradient. So basically it will be, so gradient was 12,9. So 12 multiplied by 4 by
4
5
upon 5.
plus 9 multiplied by 3 by 5.
3 by 5.
This is
48 upon 5. 27 upon 5.
correct. So this is
70
what you get, right? So
Yeah.
this is the maximum rate of change of function. You see, this is more than whatever you were getting at other points.
Yeah.
Okay, I hope that is clear. Now let's move on to the next question. Okay. For
For the previous one, 4 and I mean that from where is that number coming from?
4 by 5, 3 by 5.
Yeah.
This came from the previous question. The direction, so we were asking in which direction will the derivative be maximum. The direction will be gradient itself. The gradient points to the direction of maximum rate of change. Okay, so we had converted into a unit vector form. 12,9 itself we had converted into unit vector form. Now this is what we are using as a unit vector u, and that was this. So basically we are taking the dot product of this.
Okay, got it.
Okay, next question is find for the same function, what is the derivative in the direction -3, 4 at the same point? Yeah, it's the same point.
Only the value will change, right? Again, the same calculation.
Sorry, Samit, can you repeat?
I'm saying only the value will change, but the same thing.
Which value will change?
No, directional derivative value will change.
Change, yes. How much that comes out to be? I want you to tell me, because I'm going to explain one concept after this question. Okay, the answer is 0. One student has entered an incorrect answer. Okay, I just wanted to highlight a small point here. So the rate of change of the function in this direction is coming out to be 0. Okay. Now, what we said before this was the rate of change of function in the direction of gradient will be the maximum. And here in this direction, -3,4, the direction is coming out to be 0. So somebody had asked this question a while back, that it should be a perpendicular direction. Now let us see, -3,4 and 12,9. Can you tell whether these two directions are perpendicular to each other? How
Yes.
can you do that?
Because the dot product is 0.
Correct. So -3,4 is one direction. And the other one was 12,9, the direction of gradient. Now the dot product between these two will be 0, which means these directions are perpendicular to each other. So in one direction, the rate of change is maximum. In another direction, rate of change is 0. So I hope that point is clear to everyone. Let's move on to the next question.
Ma'am, can you just repeat that?
Yeah. So you just now computed that the rate of change of the function in this direction, -3,4, is coming out to be 0. Now, what should be a direction? Okay, let's say this is the question, and let's say I tell you that rate of change of this function in this direction, -3,4, is coming out to be 0. You tell me what will be the rate of the change of function where it will be maximum. So that direction will be perpendicular to this direction, -3,4. We saw in the previous question that the rate of change of function in the direction of gradient was maximum. Here in the direction -3,4, it is 0. In that case, these two directions should be perpendicular to each other, and this is what we verified as well. Verified that these two directions are perpendicular to each other by seeing the dot product, which comes out to be 0. Is that clear?
Yes, ma'am. And just to summarize, for a given function at a given point, if one directional derivative is the maximum and the other directional derivative is 0, they are supposed to be perpendicular. Is that what the summary is?
Yes, they will be perpendicular.
They will be perpendicular. Yes.
Yes.
Okay.
Yes. Okay, next question. Find the derivative in the direction of -4, -3. So I want to highlight one more point. That's why I want you to solve this another question, another similar question. So can you tell me what will be this value?
-1.
Minus
12.
1, is it? No, that's not
12.
correct. -1 is not correct.
-12.
-12, is it? I'm sorry, can you enter?
No, -15.
-15, madam. Correct. -15 is correct. So is everyone getting that?
I mean, which point we get the +15? What is that point?
Yeah, you tell me the maximum, and that was in the direction of gradient, and that was 12,9. Can you convert 12,9 into? Can you convert 12,9 into a unit vector?
Yeah. 12 by +9.
How much that was coming out to be?
4 by 5.
Right, 4 by 5, correct. We did that, 4 by 5, 3 by 5. So this was the direction in which the derivative was coming out to be maximum, which was 15. Now the given direction, -4, -3. Can you convert into a unit vector form?
Yes, minus 4 by 5 and minus 3 by 5.
Correct. So comparing these two directions, what do you see? This is in the opposite direction, correct?
Yes.
This is in the opposite direction. And directional derivative is coming out to be how much?
Minus 50.
Correct? So this is the direction of steepest ascent, whereas this is the direction of steepest descent. And that is why in gradient descent algorithm, we take a negative of the gradient direction. Okay. In gradient descent, we want to go towards the minimum value of the function. That is why we go for the descent direction, which is negative of gradient. Is that clear? Is that clear to everyone?
Yes.
Okay. All right. Let's.
Yes.
Okay. Next question. Can you tell this? And which concept will be used here?
Madam, Cauchy-Schwarz inequality.
Yeah, correct. Okay, so what does the Cauchy-Schwarz inequality tell you? If there are two vectors x and y, then their dot product will always be less than equal to the multiplication of their magnitudes. Okay, what are we asking here? Whether they are equal or not. Whether the dot product and the multiplication of magnitudes is equal or not. How can we tell that? That happens only in one case, when one vector is a linear combination of the other vector. Is it happening here?
Yes.
Yes, ma'am.
So y is equal to 8x. Right? So y is a linear combination of x. So in that case, this will be equal. So even without computing the magnitude of x and y, that will take some time, you can directly tell. So yeah, that's, you can directly tell by making use of Cauchy-Schwarz inequality. Okay. All right. So that was all the questions for today. You may tell whether you were able to understand or not. In case you had some doubt, you may please ask me even now or maybe later. And,
now I didn't understand the last part. Can you repeat
this
it?
one?
Yeah.
So what does Cauchy-Schwarz inequality tell us? It tells something. It tells us something about. So x and y are two vectors. How much will be their dot product? I mean, how much their dot product will compare with the multiplication of their magnitudes.
Yeah.
This, it tells us whether they are. So firstly, it is always less than equal to. That's what Cauchy-Schwarz inequality tells us. The dot product is always less than equal to this.
Right.
In which case is it equal? It is equal in the case when x is a linear combination of y or y is a linear combination of x.
Right. Yeah.
So here you see that y, you multiply x with a, you get y.
Yeah.
So y is a linear combination of x.
Okay. Okay. Yeah.
Equal. We, even without computing, we can say it will be equal.
Yeah.
Okay.
Got it. Thank you.
All right. So they were all the questions. You can still ask me if you have had any more doubts, or you can just. Okay. Good to see that you understood. That's a good feedback. Okay. There's one no. Please ask me now whatever your doubts are. I'll be happy to clarify.
Ma'am, I have a question in the higher order linear approximation of square root of 1 plus x. Will you please explain the question, answer of the question?
This one?
Yes, ma'am.
Yeah. Yeah, we did it, right? Or we did. Did you do it? One plus x cube root, cubic approximation. Yeah, this one. Okay. Yeah, we did it. So, when yeah.
Ma'am, I am solving it, but I am unable to put it. I am getting different answer.
Okay, what are you getting? Yeah, I didn't solve it, is it? Okay, no problem.
Okay, ma'am, it's factorial in the denominator.
Yeah, what did you use? Only 2
Yeah, ma'am.
Yeah, this is factorial. So if it is next term, that will be 4 factorial and so on.
Okay, ma'am. Thank you.
Are you now getting the correct one?
Yes, ma'am.
Okay. Okay, good. All right. Yeah, please go on.
Ma'am, I had a question. Like in the set of questions where we calculated the derivative in the direction of this and the maximum and the minimum and all that, that were all for the point 3,2, right?
Sorry, that was for the point 3,2, correct. That was at a given point. Yes.
Yeah, so what if we had to calculate for the entire function, like f of xy equals to x square y?
See, it depends on the function, firstly. Your function may not be, your function may be such that it will have a multiple minimas. It doesn't have a global minima. So it makes sense to, compute it at different points, right? Whatever you compute at this point will be from whatever you compute at this point. That is why the concept of point comes in. Let's say this is a 3D plot, okay? At a given point, there are different directions that you can go on. That is why a point is needed. You cannot always get a function which is, uniform, like this or like this, right? Your function may be irregular and you do need a point.
Okay, so in multivariable, we always calculate at a particular point.
Yeah, we compute at a point. Yes, because it will be different at different points. Okay, let's visualize. You can visualize a hill. Let's say, okay, this can be visualized as a hill. Let's say you are at this point, and you throw a ball. You just drop a ball. The ball will follow the direction of maximum wherever there is a maximum rate of change. Okay, it will automatically follow that one. Correct? You're dropping a ball from a hill. Okay, you cannot make the ball to follow a direction where it will slowly go. I mean, it will always follow the due to gravity, it will go in the direction where it will quickly reach the bottom. But if it follows a different path, it will take different time, because the rate of change of the hill and in that direction will be different. Okay, I mean, that's just that's an analogy to understand this. Is that clear to you?
Yes, ma'am.
So this is one point. Let's say you are at this point, things will be different at that point, right? It depends. I hope you're able to visualize this as a 3D plot. So there is more detail in the other direction as well that you're not able to see in this plot. Okay, so point is really important. Is that clear?
Yes, ma'am. Thank you.
Okay.
Hello, ma'am.
Yeah, Shruti.
Someone is trying to ask how gradient is perpendicular to the contour. Actually, his mic is not working, so he asked it in the chat.
Okay, 1 second. Let me check. Okay, gradient is perpendicular to the contour. Okay, good question, Pranab. All right, we discussed about contour plots in the last session. Can you tell me what is the rate of change of the function in the direction of a contour? So, taken this example, let's say this is function, 3D function this is, and then you cut it at different places, and then you get a contour plot, something like this. You look at.
Ma'am, your screen is not visible.
Oh, I'm so sorry. One second. Let me share. Okay, so I hope you can see this. All right, I hope you can see this. So we discussed this in the last session that how can you generate a contour plot for a given function? Let's say this is a function. Let's say this is a 3D function, and you want this is 3D function. Please visualize that way, and you wish to represent it in 2D. So that's where contour plots are useful. So let's say you this is the plot, and you cut it using some discs like this, and wherever cut this function, you watch from the top. Yeah, you watch from the top, and you see something like this. Something like this you see. This is your contour plot. Now, if you go along the line, this line, these are contour lines. Okay. What is the can you tell me what is the rate of change of function along this line? First, you should understand how you got this line. How you got this line is these horizontal discs are cutting this plot. Wherever this plot is getting cut is what your contour line is. Is that clear to all?
Yes, ma'am.
Now, if you follow this line, the rate of change of function will be 0. You follow this line, the rate of change of the function along any contour line will be 0. Now, what was your question? How are contour lines perpendicular to gradient, right? So, what is the rate of change of function along the gradient? We discussed just now.
It's maximum.
And that's the gradient. One second. So, gradient, it's the maximum, and minimum that is 0, that is along contour lines. And we just now saw an example where there is one direction d1, there is another direction d2. Here it is maximum, here it is 0, and you take the dot product, they are perpendicular to each other, correct? That's why gradient and contour lines are perpendicular to each other. Is that clear? Who had asked this question?
Yes, ma'am.
You had asked.
Ranab asked actually, but he couldn't speak.
Okay, I hope he was able to hear. So
yeah, why is it 0 along the contour line now?
Why is it 0? Okay. How did you get the contour line? Can you explain?
We got the contour line by slicing. You said slice the hill kind of thing, and we got the contour lines based on looking at from a top view.
Right. So you put the disc, these, one second. You put these discs horizontal to, so let's say this is the value of the function, f of x comma y. This is your x and this is your y. What is the value of f of x comma y at this point where this disc is kept? Some value, let's say v value. Okay. Wherever this disc is cutting this plot, the function's value will be same, isn't it? Are you able to visualize this thing? This is a 3D plot, sort of hill, and then this is cutting, this disk is cutting this hill at a point. There will be same value V at all these points, isn't it?
Matlab f of x comma y, or what you said, v is a constant value. That is why the derivative will be 0, you're saying.
Yes, yes, yes.
Okay, I understood.
Okay, good. All right, I'll stop share now, and I hope things were clear. If not, you can post on Discourse and we can see there. All right, thanks for joining in. We'll see you in some subsequent session.
Thank you, ma'am.
Yeah, thanks for joining.
Thank you, ma'am.
Bye, everyone.